Alright, this video is going to be a quick run through on how to derive exponential functions, and it's actually fairly easy. A lot of people don't really like e to the x, but it's not too bad to derive. Right here I graphed the typical f of x equals e to the x graph. Something common about e to the x is it always goes through the point at 1, here at 0, 1. And if I asked you to take this graph and sketch me a picture of the derivative, just based on what it looked like, you would be studying all of the slopes. So you would look at the graph and pick a bunch of points. So I'm going to pick a bunch of random points here, and you would study all the different types of slopes and what happens. And e to the x has this asymptote over here going towards 0. It never actually touches 0. It just kind of continues out here. It keeps going out to negative infinity, getting closer and closer and closer. So if I looked at it and I started asking you what the slopes are out here, you'd say, well, it's really flat, almost 0. Not exactly flat, not perfectly 0, but really, really close. And then as I work my way up the graph, you'll notice the slopes are all getting steeper and steeper and steeper, but they're all positive. So positive, positive, more positive, really, really positive up here. So if you graphed all those steepnesses as your function, your derivative, you'd say it's really, really close to 0, so somewhere out here close to 0, getting more positive, more positive, more positive, more positive. Turns out the graph's identical, which means the derivative, f prime of x, is the exact same graph as f of x. It's e to the x. So when it comes to deriving exponential functions, I always tell kids it's easiest just to memorize it. If somebody asks you the derivative, d dx, of e to the x, the derivative is always e to the x. And you're good. So that's kind of nice, kind of easy. There's a chain rule part of this that's going to come into play. So that's what we're going to focus on today, is this chain rule piece. And the chain rule for exponential functions really has to do with, what if it's not e to the x? What if it's e to the x squared, like this? Or e to the sine of x? Or e to the 3x to the 5th power. The second I start changing this thing, this power, I got to use the chain rule. So here's how it looks. I'm now finding e to the u, where u depends on what I make up, some sort of an equation. But I still want d dx. I still want the derivative. So when I derive e to the u, it's kind of like e to the x. E to the x derives e to the x. E to the u derives to e to the u. But you have to add on something a little extra. You have to add on the chain rule, which means you got to derive this portion up here. You got to take du dx and multiply it by your answer. And really, if you can memorize, I'm going to put a box around this, if you can memorize this formula, you'll have exponential derivatives down real quickly. These are nice and easy once you do a few. So I'm going to give you an example here. Let's take maybe these couple here. We'll take e to the x squared. So example 1, let's say y equals e to the x squared. And I want to find dy dx, the derivative. What does that equal? So here's what you do. In this case, u is our x squared. And remember, we're going to add this little du dx to our answer. So du dx is the derivative of u with respect to x. X squared, if I derive it, is a really quick power rule. It's 2x. So there's my 2x. So my answer, my derivative, is going to be e to the u du dx. And so I'm going to plug in. E to the u, it's really just this. And du dx, that's this. So I'm going to be plugging in some parts for these things. I'm going to make it, final answer down here is going to be e to the x squared times 2x. And that's my derivative. Dy dx equals this. And you can rearrange it, maybe put the 2x in front. A lot of people would much rather write their answer as 2x e to the x squared, because it looks a little nicer, equals dy dx. And that's okay too. I'll probably do that most of the time. But really, that's how the chain rule works with these things. So you can get fast. You can go straight from this e to the x squared to the answer and do most of this in your head once you get this down pretty well. But if you're not doing them correctly, then you should slow down and probably show the steps in between. kind of practice this until you're ready. So I'm going to show you maybe one more example for this video, and then you should practice and make sure you got it down on your own. Let's say you had f of x equals e, and we're going to do to the negative square root x power. And I want to find, what does f prime of x equal? So in this case, u is negative radical x, and du dx, the derivative, is going to require the radical rule. The negative sign, I'll just leave it right there as a negative sign. But radical x, it's the derivative of the inside, that's 1, over 2 times itself, 2 radical x. So my answer is going to be taking the original and the derivative, putting them together here. It's going to be e to the negative radical x, that's e to the u, times du dx, negative 1 over 2 radical x. And there's my answer. Probably want to rearrange it so the negative 1 and the e are together. So negative e, negative radical x, and then all divided by 2 radical x. And I think we're probably good at that point. F prime of x equals all of this. I got my final answer. And that's the basics. That's how you do exponential functions with differentials. Later on, we're going to learn how to do integrals with e to the x. So that'll be in another video that we post later.